Hey, welcome back. We're going to continue with the simple and preflighted request demo. We finished looking at post request, and now we are going to continue with put request, as we mentioned. So we need to make a few changes to our API. I have let me get set up to the basic setup, which is very general. Then I'm going to add a put mapping from API CORS registration. So let's assume I'm going to be updating the registration we did with register. So I'll put here an ID just to improve the semantics of the put endpoint. So this is going to be test put. What's the request body looking like? Fill named record. Okay. Name record. Okay. So I'm not really doing anything, but I want to return the value that is sent there. So again, this return type will be a string. So this is a put request. We just want to see if the how the request is sent to the server by the browser. Let me restart the server. Go into the client. I should change this to put. Should we? No. Let me create another one. We may need to go back to the other one or submit later. Let me call this update name and API calls registration slash one. That will be the ID. The name field is still the same. Let me change the method to put. Name field, let me change it to edit. Let's consider that an update. So I'm going to start again without the content type. I want us to see the effect when we only change the HTTP method name. Because if we have so many changes, then it is going to be confusing. We come over here, let's create another button. I'm going to call it update name. Just trigger a put request to the backend. Let me see. Is that all? Yes, actually. Yeah, that is all. That's all really. Let's see what happens. If there's anything, we shall update. So I have a put request, and we already know a put request, put HTTP method is not considered a safe method in the course specification. So previously, we saw that when we just add a post request um, without any fancy or without any illegal content types, then the request would still be treated as a simple type. We saw the request with post. Um, with a form URL encoded content type, and it went without a preflight. But when we added a JSON content type, then there was a preflight, and that was very clear. So what about for put? So I'm going to clear everything here, console, so that we can see the action. All right, so let me save that. It's going to send a request right away to fetch. That's okay. We don't want that. So let me send a put request. What will happen? Update name. Great. So you can see automatically there's a pre-flight request. Let's open it before seeing the why the thing failed. So just because we changed our request to a put, there was automatically a pre-flight request. And let's look at it. The request headers access control request method is a put, and basically that's the only request header sent. So the only thing about this request that makes it a CORS request is that it's cross origin, in which case there's the origin header to inform the server, and the fact that we're using a non-simple HTTP method. So the browser deemed it fit to send this first in a pre-flight request to the server, and then try to see what the server says. And the server responded with allow headers, allowed methods, put is there, similar to what we saw previously with post and the headers. It is only sending back what is allowed and what is requested for, because anyway, in any request there's only one method, but still it is telling us that put is allowed. It doesn't list all the headers that are allowed, it just returns the header that is accepted. But it could also be a list of headers. It could also be the list of headers that are allowed on the server, and that is allowed by the core specification. It doesn't have to behave like the request headers by returning only the requested headers and not the full list of allowed headers. Uh, in this case, I would expect even a list of headers, but it's okay. Maybe because in the default mode we're using cross origin, which lists, which sends. Which accepts wildcard. And this value would also be a wildcard if it was for origin, but for this particular case, it is just the specific method, which is okay. We are going to have somewhere we put the specification side by side with how Spring Boot works and be able to judge like that. But here we're just exploring, and the purpose of this demo is to see what triggers a pre-flight request and what doesn't. So we've already seen this for put, and response is an error. Otherwise, it should have been displayed here. So let's go to the request. It is a HTTP status 415. We already saw this, and it has to do with the content type. And remember, I hadn't included the content type specifically because I just wanted us to see a pre-flight request sent only on account of the HTTP method, not on account of the content type. So now that we've seen that, I can add the content type header and make it application slash JSON. So that's basically what we're sending. So we expect the server to respond with the updated name so that we display it. So let me clear the network logs. Yeah. Let me save the changes. We're going to first see our request, and we clear that so that we leave room for the update. So when I click update, now all the requests are successful. So you can see the pre-flight request is sent again, and the values are still the same, and then the actual request is sent. And indeed, we get the course headers are there, but most importantly, the value we expected is received, and it has been displayed here. So that is just a demo of how put request triggers a pre-flight. So what happens, because on the server side, again, we always start with the lax setup in the default, which is what Spring Boot does when you just add a cross origin annotation. But let's play with it a bit. Why don't we put a list of allowed headers instead of allowing everything? Because in the default mode, all HTTP methods are accepted from cross origin requests. So if I change this and okay, the parameter is called methods, and I list the accepted methods. Get okay. Head. Excuse me. And then I want to exclude the. Let me exclude a put, or let me start with. putting it there, and we just see what happens when we move from the wildcard to specific headers. Does it list all the allowed headers? Does it only return put, which is the requested header? I want us to clear that out of the way so that we can go ahead and try to put a header that it. Um, we try to remove the put method from the allowed method. So let me refresh that, and then I update. So let's see the pre-flight request. So actually, you see, this is my hypothesis is the result is now here. I was saying that perhaps we're getting only one method simply because uh, the server was allowing anything. But if we list specific HTTP methods, then the pre-flight request will return the list of allowed HTTP methods, all of them. It's not treated as secret as the custom headers. We looked at the situation previously where we requested for one custom header, and if it was not allowed on the server, then the server would respond with forbidden instead of returning the list of allowed headers or the allowed header. And this would end up giving us an error message that is not informative of why exactly the request failed. And at first, it didn't make sense, but it made sense because if I sent a request for a custom header, and instead of returning with a forbidden response, the server returned the list of allowed headers. If I'm an attacker, information has just been leaked to me by the server, and then I can try to become creative and think of other ways to exploit the allowed servers and the naming of the allowed headers, and the naming of these headers could give me several ideas on what kind of attack to craft. So for the sake of custom headers, that is understandable. Now coming to the case of custom to the case of HTTP methods that are allowed and not allowed. For example, put. When we requested for put method, the server in the default allow all mode responded with a put header. Okay, but then when we listed the allowed headers explicitly, as we did here, the server sent all of them over because this is not secret information. The HTTP specification is an open specification. There is nothing any developer is going to define as a custom HTTP method. So we're not really leaking any information. We're only sharing the allowed methods, which are already known generally. The list, the set of headers is really small, and there's nothing unique and special about them. So this does not really expose much security risk. So I just wanted to clarify that. So the hypothesis is clear. The returned allowed methods is actually the exhaustive list of allowed methods. So if we even added here delete method, it will be returned in the pre-flight response. So let me just do this again. I can update name, pre-flight request sent. You see, delete is now here. All right. So that's clear. And then what about if we remove put request? If we remove put from the allowed request methods, what will happen? I can tell you it will be similar to the case where we had some headers in the request that are allowed on the server and some were not. So the server will return only the set of headers, the set of request methods that are allowed. And the browser will be able to read the allowed request methods and compare with the list of requested ones and be able to behave accordingly. So let's just see that in action. After all, this is a demo. So I'm going to run update again. So the options request has failed. Okay. Uh-huh. All right. I'll admit this is also surprising to me, but it's very interesting. We're learning. Basically, the requested method was put, and allowed methods. Where is it? Okay, I don't see, but let's look at the error. So the error is again the generic one. We can see here. So let's look at the server. Okay, the server says the HTTP put method is not allowed. Great. So this is also something I was not expecting. My expectation was according to the course specification, and now the server is returning that. And it's a bit surprising, but also very interesting because, again, I'll just repeat this. Every framework can implement this in a number of flexible ways. The course specification has a lot of flexibilities, but ultimately, at the end of the day, as long as the user data is not exposed, right? The other concerns of the browser being able to accurately interpret some errors might be a secondary consideration. But I would think this is something that it's really going to be interesting to discover the inner workings of Spring Boot and Spring CORS configuration. But I'm finding things that are a bit different from because I really took time to understand the course specification. And basically, this is not something I expected. I was expecting to see a list of allowed HTTP methods, like we did with HTTP headers. Then the browser would say, "Okay, put is not in allowed according to the response." But let's just try it again. Yeah, it has done the same thing, and on the server, it's not allowed. So the pre-flight and the request have both been rejected. And again, most importantly, the pre-flight is sent. The dynamics of how the response is returned from the server, those are implementation details. But the ultimate thing is the request should not be allowed if it's considered to be violating the core specification and the course configuration. So on our side, we configured the server to not allow the put method. And indeed, the browser has followed that. The server responded with a forbidden response status. So the browser knew to not proceed with the request. And you can see the server error is very clear here. Forbidden is sent because HTTP put is not allowed. Okay. So yeah, that is it. And we've already seen the scenario where if put request is allowed, then the pre-flight request will pass, and the actual request will pass. So we can just do that so that we leave this demo in working state. And remember, cross origin is not the only configuration option. So in the future, we're going to look at all of the others and see if they behave the same way, and also really just dig into how Spring Boot implements the course specification. So I run update and the request is successful. So the full list is here. I expected that if put is not in the list, then it should return get head and delete without put, so that the browser will tell us that put is not allowed according to the received access control allow methods. But again, this is a generic error, not ideal, but as long as the request is not allowed, ultimately, it's all about protecting the user's data from unwarranted access. So that's it for put request. And again, I'll end this video here. And in the next part of the demo, I'm going to discuss something a little bit about the response side of things. So basically, here we've been looking at the request side of things. The server is trying to request, the browser is, the script client side is trying to request for access from the server side. So what about data that is sent by the server? How does the browser handle it, and which CORS response headers are used to control access to content from the server that the browser did not know about before? So we've spent a lot of time moving mostly demoing things from the client side, but in the next demo, we are going to set some data on the server side and send it over to the client and see how CORS governs those. So I'll end this here. And as a bonus, we might also be able to cover a little bit about max age um, response header. So just a spoiler alert, we are mostly going to be talking about access control expose headers and access control max age. So thank you very much for your attention, and see you in the next demo.